So, as you guys know, the complex numbers can be plotted on a plane. You guys learned that in algebra, right?
Yeah.
So, suppose we have a complex number written in standard form, which is x plus yi. Then x is what we call the real part, and y is what we call the imaginary part. And I is, of course, the imaginary unit, square root of -1. And so we're able to plot this on a plane where the x-axis is called the real axis. We label that with RE, and the y-axis is called the imaginary axis, labeled with IM. And the point is just going to be x plus yi is going to be plotted such that its real coordinate is x, and its imaginary coordinate is y.
Imaginary?
Yes.
Imaginary numbers. Like, how does that even work?
They're not real.
How do you count imaginary numbers?
They're unreal.
Application of this.
You'd be surprised.
Like, have you ever wondered, how do you count I of something? I have I apples.
Well, there's no such thing as I apples.
How does that even work?
But if you guys go into any field of electrical engineering, then you guys are going to be doing imaginary numbers all day long. So. And you'll see why, because there's a very close relationship between imaginary numbers and trigonometry. So anytime we have a periodic wave, such as in signal processing for electrical applications, those are all represented using complex functions. And you'll see why in 6-6. It was the easiest class in college. It's unbelievable. I don't even know what they do in that major. Anyways. Okay, guys. Okay, and then the magnitude of a complex number we represent using absolute value bars. And the magnitude is the square root of x squared plus y squared. Looks very familiar, doesn't it? So that'll just be the distance from the point to the origin on the complex plane, right? Because this y component is y, and the x component, or the real component, is x. And so that means the hypotenuse is square root x squared plus y squared. And so the magnitude is always the distance from the point to the origin on the complex plane.
Hold on. Wouldn't it be x squared minus y squared since I squared equals -1?
No. The magnitude is x squared plus y squared square root.
Why would squaring I and getting a -1 not make it minus?
I'm not squaring I. I'm just squaring the imaginary part, which is y.
Okay.
Right? Graphically speaking, you can see that the magnitude is obviously the square root of x squared plus y squared, not x squared minus y squared. Okay? And then the conjugate we represent using a bar, right? And overline. And the conjugate is just the imaginary part flipped side. So it becomes x minus yi. And so if you plot the conjugate, it's just going to be a reflection across the real axis, right? So this is the point x minus yi.
Wait, is that how you write a conjugate? Put a line over it?
Yes.
I've never seen that.
Well, your teachers, never mind.
Wait, do you remember this?
No, bro, we didn't teach any of this.
It's very important to control my tongue. Okay, any questions? So plotting complex numbers, finding the magnitude, plotting the conjugate, that's question 1, which I will give you 1 minute to do. One minute to do. Question 1. So make sure you're quite clear what the real part is and what the imaginary part is. Hopefully you guys also see why this comes right after vectors, because they're so similar.
I mean, it's absolutely insane to think about. It's crazy.
I mean, at least it's not.
But I think it's like perhaps it's intended to be fear for the supposed to be hope for those who will assimilate and fear for those who won't.
You can't really be yourself until you start following God.
I thought you were
Because God frees you from sin, you're a slave to sin. It's not yourself. Right, Mr. Nye?
Are we all finished? What?
Before, there's no such thing as
Ask someone else who thinks.
All right, let's keep going then. Your answers should have been 2, square root 13, square root 5, and 5.
Sir,
9 plus 4.
for the magnitude.
Yeah, 3 squared plus 2 squared, 13 for 1b. Magnitude is 2. Okay, I'll do maybe 1d as an example. Right, negative 5i is going to be right here, negative 5i. And then the conjugate, which is positive 5i, is going to be here. All right, let's continue.
Wait, how does that make the magnitude?
X squared plus y squared, square root. So
Oh, yeah. Wait.
let's talk about the trigonometric form of complex numbers. This is very important setup for our very fun lecture on 6-6.
6 is hard.
I think it's not hard.
So then you have to make
Okay.
make everything perfect.
So there is one form for complex numbers that we just learned. That's standard form. All right, so that's x plus yi. Let me write z equals x plus yi. Shh, Luna, focus. Okay, and what is the magnitude of a complex number in standard form? It's just going to be the square root of x squared plus y squared. We just learned that. But there's also another kind of form that's very useful, and that's the trigonometric form. Trigonometric form. My handwriting is really good today. I mean, it's like pretty, you know. Anyways, trigonometric form is going to look like this. R times cosine theta plus I sine theta. Okay, here R is going to be the magnitude, and it's labeled R because it's a radius, kind of. Okay, and then theta is going to be the angle that is made with the positive x-axis. Very similar to the vectors we just looked at, right? Okay, frequently in some older textbooks, you'll see the shorthand form where people will label this cosine theta plus I sine theta with CIS, cis. Nothing to do with cisgender. It's CIS stands for cosine I sine. And so that's a shorthand that some people will use. CIS. Alexandra? Hello? Birthdays. Alicia, Annika. Am I saying your name wrong? Anika or Annika? I have some friends who go by Annika. So.
Sure.
Yeah. Radius. Okay, let's think about this more. Okay, so in trigonometric form, r always has to be greater than 0, okay? R must be greater than 0 because you can think about r as kind of being the radius. So the magnitude of z in trigonometric form will always be equal to r. Let me draw this on a diagram, and all of this will become very illuminated to us. All right, suppose that we have a complex number here, and this is our z, okay? And in standard form, this is x plus yi, but in trigonometric form, this is going to be, right? If we took this form here, and we brought it out here, and let's say we converted it from trigonometric form to standard form, then we would have z equals r cosine theta. That would be the real part. And then the imaginary part would be r sine theta times I. Yes? So that would be converting trigonometric form to standard form. So how would we plot that, right? If we were to plot that, then on this diagram, this length here is the real part. And so that would be r cosine theta. And then this length here is the imaginary part. So that would be r sine theta. And if we were to calculate the hypotenuse, what would that be? That would be r, right? And so what does that tell us about this angle? This is theta. And so as you guys can see, if we have an arbitrary point that's in the complex plane, all we need to do in order to write it in trigonometric form is to find the radius, that is the distance from the origin, and then the angle that is made with the positive x-axis. And that allows us to immediately write this complex number in terms of trigonometric form using r and theta. So it's quite similar to vectors. And later, once we get to polar coordinates, you'll see even more similarities to that. You guys learned polar coordinates in algebra?
Polar coordinates?
Maybe not.
Like the at the North Pole?
Yeah, polar bear, polar.
Wait, what are the coordinates in North Pole?
Okay, let me give you guys some examples to go through. Suppose that we're asked to convert this to standard form. So we have maybe 3 times cosine pi over 6 plus sine pi over 6 times I. The I always comes before the sine. Okay, that's a convention. If you write it after the sine, people will laugh at you in the real world. Okay, so just think. Always has to follow CIS, right? Cis.
Excuse me? Yeah, that got didn't it?
Yep. Well, the CIS came first, okay? All right, so how would we write this in standard form? We would simply evaluate these trig functions. So cosine pi over 6 is root 3 over 2. And sine pi over 6 is 1/2. So we would have root 3 over 2 plus 1/2 I in the parentheses, and then we would expand that to be 3 root 3 over 2 plus 3/2 I. All right. And then how would we plot this? Well, we could plot it using the coordinates that we've just found, right? We know that x has to be 3 root 3 over 2, and y has to be 3 over 2. But actually, a much easier way to plot it is just by using the trigonometric form. So in this case, we know that 3 has to be r. It's the magnitude of our number. And 3 is also the distance from the point to the origin. And then we know that theta is pi over 6. Okay, notice that the angle has to be same for both of them. Otherwise, that's not real trigonometric form. And so these are both going to be our thetas. And so if we were to plot this, we simply know that it has to have a radius of 3, a magnitude of 3. So this has to be 3. And then the angle made with the positive x-axis is going to be pi over 6. So that's how we would plot this point. Any questions?
Nah. Wait, how do you know it's in quadrant 1?
Because it's pi over 6 as the angle. The angle is always being made with the positive x-axis, counterclockwise. All right, I'll do one more example. Let's say we had 5 cosine 7 pi over 4 plus I sine 7 pi over 4. How would we graph this? This makes a radius of 5, right? And an angle of 7 pi over 4. So this should be here. So the radius is 5, and the angle is 7 pi over 4.
Wait, does it matter what quadrants are in for this lesson?
What?
Do quadrants matter for this lesson?
Of course.
Like, is it like restrictions or is it like still?
It could be any quadrant.
Okay. It's fun. It's not fun.
All right. And so this allows us to express any point using a radius and an angle. And that way we don't have to find the coordinates. We can just look at the radius and the angle. Okay, I'll let you guys do question 2. 3 minutes.
3?
Yes. Just work harder.
Oh.
I mean, you're just writing on it, right?
Oh, we should get a real one. And like, if you don't get the lesson, you don't have to
What?
Or at least.
You gave us like 2 homework passes, and like if we don't like understand the lesson, you can use a homework pass and not do the homework check.
I'm dropping homework checks. Isn't that kind of equivalent? I'm dropping a certain percentage of homework checks.
Test correction at the end.
Wait, I don't know how to do Jennifer.
I wasn't gonna give any plus. The part that I know what, yeah,
For the cosine pi, I don't get, is that like 1?
-1.
-1. And how do you know it's -1?
Draw it on the unit circle, right? Cosine pi, x coordinate, -1.
And then sine will be
0. Because you're
oh,
at
0,
this
0, -1.
-1's comma 0.
Would we still be cool about? Wait, let's test it out. Let me up. It's okay. I'm not going.
What are you doing, bro? You do not have
And then the final.
Luna, work on the classwork. Yeah.
For 2C, if at pi, isn't sine 0? So then what would happen to this? Would just be nothing? Would just
Yep.
all be 0? So then the answer would be -2?
Yep.
And then how do I,
That just means the real part is -2 and the imaginary part's 0.
so I can just put, it will be like on a thing?
Uh-huh.
Okay, got it, thank you.
But I would say our hearts are weakened compared to you.
They just think they're superior.
Well, I do think God's superior to us.
Bobby, I collect the classwork at the end of the class, by the way. You did it? Good.
Wait, so for number 2C, would it just...
-2? Cosine pi is -1.
Huh?
Cosine pi is -1.
-1.
Cosine
Oh
pi.
yeah, this is negative. But like, since this is 0, the I would be 0, so we wouldn't need to care about it.
Mm-hmm.
Oh, okay.
He literally like worked
Yeah.
like went like this.
Guys, let me continue. I hope you guys finished.
Wait, is it 0? Wait, is it? Wait, bro, if I'm correct, like I got.
I'm starting the lecture.
Is C 2?
No.
Wait, but like in a theoretical scenario, wouldn't this be 0? So it would be 2 times 1.
Cosine pi is 1? No. -1.
Negative. Oh, -2. Guys, I'm almost right.
2 times 0?
I still have to write it? 0I?
Well, it's definitely not I. Okay. Okay, guys, let's talk about the backside. I would advise you listen to the lecture if you want to know how to do the classwork. Ruhan. Yeah, listen. Now's the time for listening. Yeah. Okay, so we also need to know how to convert from standard to trigonometric, which is harder, isn't it? So the first step is always to figure out the magnitude. It's maybe easiest to do an example. Let's say we're trying to convert 1 plus root 3i. It's not the same as the classwork, isn't it? 1 plus root 3i, and let's say we're trying to convert it to trigonometric form. The first step is always to figure out the magnitude, because that will tell us r, right? Right, if we were to plot this on the, what's it called, complex plane, we would have it somewhere here, 1 plus root 3i. If we're able to calculate this distance here, that immediately tells us r. And then if we're able to calculate this angle, that's going to tell us theta. And we'll have the two numbers that we need to have trigonometric form, right? And so the magnitude is not hard to calculate. We simply have the square root of 1 squared plus root 3 squared, which is 2. right? And so that immediately tells us what r has to be. And so that's halfway, we're halfway done. So what we do next is that we are going to want to factor out this radius from the standard form here. And that's going to give us cosine plus I sine, correct? So if we factor out a 2 from 1 plus root 3i, we're going to have 1/2 plus root 3 over 2i. And so the remaining step is simply to figure out which angle theta corresponds to these two values of cosine and sine. Alternatively, you could also plot this on the plane or on the unit circle, right? Yeah, 60 degrees. You could plot this on the unit circle, and you know it has to be somewhere here, 1/2 comma root 3 over 2. And our task is simply to figure out which angle this is. And if you know your unit circle well, you simply know that this is cosine theta, comma sine theta for theta equals pi over 3. And so our final answer would be 2 times cosine pi over 3 plus I times sine pi over 3. Remembering that the I has to come before the sine. Okay, so it's very important that these two angles have to be the same. They can't be different. Otherwise, you don't have trigonometric form.
Wait, I need to take a look.
Leisha?
Did you just, like, divide the 1 and the square root?
Yeah, I factored out 2.
Factored out 2.
So essentially, I divided it by 2 and brought it out to the front.
Wait, how did you
I divided it by 2, and then I brought the 2 out to the front. All right, any other questions? I'm not done.
Not?
Nope.
Oh, okay. So, like, you solved the 1 square root.
Yeah. Okay, guys, let me keep talking. All right. So this works whenever we have easy angles. So whenever we have angles that we know well from the unit circle, like pi over 6, pi over 4, this works well. However, that's not always the case. Suppose we have a vector that's like this, okay? Suppose we have -3 plus 4i. Okay, if we were to graph that, that's going to be, did I just say vector? It's not a vector. Complex number. That will be here, -3 plus 4i. Okay, so we're going to do the same exact steps. We're going to figure out the magnitude, or the radius, the distance between the origin. That's going to be 5, right? This forms a 3, 4, 5 triangle. And so our magnitude is 5, so we factor out a 5, and we're left with -3/5 plus 4/5 I. The problem is we don't know what angle corresponds to these values, right? It's not a unit circle coordinate that we're familiar with. So for these things, in order to calculate this angle, we have to use the same formulas that we learned for vectors. We have to use an arctangent. Okay, and so because this thing is in quadrants 2 and 3, we're going to use the pi plus arctangent y over x formula. And so that tells us that theta is going to equal pi plus arctan y over x, which is -4/3. Okay? And so that tells us that r equals 5 and theta equals pi plus arctan -4/3. This is really the exact same question as the vector question, except now we have it as a complex number. So it shouldn't be confusing at all.
Hold on, wait. What was the alternate 1 and 2 formula?
There's no pi, it's just arctan.
1 and 4.
Just arctangent, right?
Oh, gotcha.
Okay, so our final answer would be 5 times cosine pi plus arctan -4/3 plus I sine pi plus arctan -4/3. Okay, I just wrote it in the standard form, right? R cosine plus I sine. Not standard form, standard trigonometric form.